So this is the beginning of Math 5A, and the first few sections are more kind of review stuff on pre-calculus that will then come back into the calculus world. So we're going to talk about section 1.1 and 1.2 in these videos. And the first question that students may be asking themselves is, what is calculus? And the answer to that is, it is the study of how things change. Okay, so there's two basic areas, and one of them is velocity. And so we want to remember that distance equals rate times time. So d equals r times t. So down here is a graph that shows it's a distance time graph. So along the bottom is time, and then along the vertical axis is distance. And what we see here is the graph shows a linear rate or slope of the line. And that tells us that as time is going and the person is gaining distance, that they're doing that in a consistent, constant fashion. However, for B, we have the flight of a projectile. So imagine like throwing a ball up into the air, and it comes up and it goes back down. So over time, its height is lower, and then it's higher, and then it's lower again. So when we want to find out the rate or slope of this graph, it's not going to be like it is in the first graph. In the first graph, we could find the slope of that line. We know that as long as we have 2 points on the line, that we could find the slope between them. You know, if we take ourselves way back, we would go y2 minus y1 over x2 minus x1, if you're just looking at the 2 points I created there. And then we'd have 10 over 1, or just 10. So the rate here is something like 10, miles per hour, or 10 meters per second, or something like that. But in the second graph, when we're asked about the rate and the slope of the graph, it's a lot harder because it's not linear. So the rate of this object here is going to be different than the rate of the object here, which is definitely going to be different than the rate of the object here, and then here, and here, and so on. So at different points on that graph, it has a different rate slope. Okay, so it's different. Okay, so it varies depending on where you are on that graph. And so what we do a lot in the beginning of calculus is talk about that. How can we take a graph like the flight of a projectile and find out the rate of change, how fast something is moving at a certain time? The second thing that we do, and this is towards the end of this semester, is finding the area. So if we think about the first graph, if our job was to find the area under the curve, if I was to just draw a line like this, and you're asked to find the area under the curve, so this space here, and you're asked to find that area, hopefully you would recognize that what we have there is a triangle, and that the area of a triangle is 1/2 times base times height. So the base of this triangle is 5. And the height of this triangle is, it looks like 50. So if we multiply that out and do the work here, we should get, let's do it, 0.5 times 5 times 50. We're going to get 125. No surprise there. And that's going to be some sort of units of area, depending on what is in the graph. But if we ask that same question for B, is it possible to find the area in the second graph? It becomes a lot harder. We no longer have a geometric shape like a circle or a square or a triangle that we can pretty easily find the area of. So instead, what we do is we use calculus to do this. And again, that shows up around chapter 4. So we'll be doing that then. So a few things that are good reminders for calculus from pre-calculus are just the reminders of even and odd functions. This can tell us a lot about the graph of a function, and that's why it's helpful in calculus. So a function is even if we plug in negative x into the function, and then out comes the same function that we started with. So if you have that, then your function is even, and it'll have a symmetry respect to the y-axis. So as a really basic example, something like y equals x squared, if I put in a negative x, and you do negative x times negative x, that's still x squared. And then a really basic graph of that would be a parabola, something like this. And we see that it has symmetry over the y-axis. So that's an example of an even function. An odd function is symmetric with respect to the origin. And what happens is when you put in a negative x and then typically manipulate that, you're going to come out with a negative times what you started with. So basic example of that would be x cubed. So if we put in a negative x and then cube it, that is a negative x times a negative x, which is x squared. X squared times negative x is a negative x cubed. So notice it's just like x cubed with a negative in front of it. And when you graph x cubed, it's going to look something like this, more or less. And the idea there is it's symmetric with respect to the origin. So we have a point, say 1, 1. We're also going to have the point negative 1, negative 1. So that's just an example of an odd function. Increasing and decreasing functions, it's just good to remember. This is kind of a, a more calculus type definition, just in terms of that higher level notation. But all this is saying is basically, if you have an interval on a graph, so from here to here, that interval is going to be increasing if f of x1 is less than f of x2 whenever x1 is less than x2. So all this means is you can see f of x1 as y1, you could see f of x2 as y2 if you want it. And really all we are saying here is if you have an x that's less than another x, then the y is going to be less than the other y, and that's going to create a function that is increasing. Okay, so heading up to the right. Alternatively, we'd be decreasing if our y2 is less than our y1 whenever x1 is less than x2. So we still have our x1, we still have our x2, but in this case, the y1 is going to be greater than the y2. So then that creates a graph that's going down, decreasing. The difference quotient is something that students should have learned in typically higher level algebra as well as then into pre-calculus, but it's something that comes back in calculus, so we'll practice that. This is just the form of the difference quotient. So pay attention to that. We'll see an example. And we've got a couple definitions down at the bottom. A mathematical model is a mathematical description of a real-world phenomenon, and a linear function is any function that graphs into a straight line. So those should be familiar. So now what we're going to do is we're going to take a look at some examples of some of these things so that students can kind of be reminded of some of the stuff that'll be really important to see in and to be able to do things that we do in calculus.